Today we will discuss about capacitors. A capacitor is a fundamental electronic component used in electrical and electronic circuits to store and release electrical energy. It is often referred to as a capacitor, or cap for short. Capacitors are widely used in various applications, ranging from simple filtering and coupling in audio circuits to complex energy storage systems in power electronics. The basic concept behind a capacitor involves the storage of electric charge on two conductor plates separated by an insulating material known as a dielectric. When a voltage is applied across the plates, positive and negative charges accumulate on the respective plates, creating an electric field between them. The ability of a capacitor to store charge is measured in units called farads. Capacitors are commonly used in Arduino projects for various purposes, including voltage regulation, noise filtering, debounce circuits, and timing applications. Here are a few examples of how capacitors can be used in Arduino projects. 1. Decoupling and noise filtering. Capacitors can be used to filter out noise and stabilize the power supply voltage for your Arduino. Placing a small ceramic capacitor, typically in the range of 100 nanofarads, between the power and ground pins of the Arduino can help smooth out voltage spikes and provide a stable power source. 2. Energy storage. In some cases, capacitors can be used for short-term energy storage, especially in low-power applications. 3. PWM filtering. If you're using pulse width modulation (PWM) for controlling motors or LEDs, capacitors can help smooth out the PWM signal to create a more gradual transition between on and off states. 4. Analog filtering. When interfacing with analog sensors, capacitors can help filter out noise from the sensor signal, resulting in more accurate and stable readings. 5. Timer circuits. Capacitors can be used in conjunction with resistors to create simple timer circuits. For example, an RC resistor capacitor circuit can be used to create a time delay before a specific action or event occurs in your Arduino program. 6. Debounce circuits. Mechanical switches and buttons can generate bouncing signals when pressed or released. Using capacitors in combination with resistors can create debounce circuits, ensuring that the Arduino receives a clean and stable signal from the button. When using capacitors in Arduino projects, it's important to choose the right capacitor type, capacitance value, and voltage rating for your specific application. Be aware of polarity if you're using polarized capacitors, like electrolytic or tantalum capacitors, and consider the capacitance and ESR, equivalent series resistance, when selecting capacitors for filtering applications. Remember that capacitors can impact circuit behavior, and their use should be guided by your project's requirements and your understanding of their electrical properties. Always refer to the Arduino documentation, relevant datasheets, and electronics principles when incorporating capacitors into your projects. Thank you so much for watching this video.